I'm Jeff Saarela. There's an unfortunate idea that museums are old, dusty, and unimportant places filled with stuff collected by eccentrics and oddballs. That's mostly not true. There might be the odd eccentric. Museums are science institutions. For over 100 years, science experts at this museum have been generating new knowledge about the natural world and building up a world-class natural history collection. Specimens are at the core of all museums. We have more than 14.6 million of them. Specimens inform the research that museums do and the exhibits they develop for public education. Natural history collections represent critical baseline biodiversity data. Every single collection deposited in a museum represents a unique and persistent data point accessible to scientists into the future. For over 100 years, the Canadian Museum of Nature has had a special focus on studying Arctic biodiversity in Canada. Today, our expertise is focused in the museum's Centre for Arctic Knowledge and Exploration. Through hundreds of museum expeditions and tens of thousands of collections of Arctic fishes, birds, mammals, parasites, marine invertebrates, insects, spiders, mosses, algae, lichens, vascular plants, Pleistocene mammal fossils, and even Arctic dinosaurs, we've been building a permanent record of Arctic biodiversity, one collection at a time. We house the world's best collection of Arctic plants and animals. Our Arctic specimens are the basis of thousands of pages of public scientific knowledge. As Mark said, our Arctic collection will be showcased in this building next year when we open the permanent Canada Goose Arctic Gallery. It's going to look kind of like this. Colorful, like the Arctic. Scientific discovery of biodiversity in the Arctic began some 200 years ago by the explorers searching for the Northwest Passage. Many Arctic species of plants and animals were first described from specimens collected on these expeditions. Some of this material eventually made its way back to Canada, to this museum, and some of our oldest collections come from those trips. So we have plant specimens collected by Sir William Parry in the high Arctic Islands in about 1820, and specimens collected in the same decade by John Franklin and his men on their overland expeditions on what is now mainland Nunavut. Natural history collections can provide baseline data for comparative analyses of past and present environmental conditions. They can uniquely allow investigators to look back in time. A recent study of an Arctic bird species, this one, compared mercury in birds today with mercury in birds collected decades ago from museum specimens they were sampled. And they found that birds today have drastically elevated levels of mercury in their feathers. Mercury is very toxic. Over a third of those historical birds used were from specimens in our collection, collected in the early part of the last century. If these specimens had not been collected 100 years ago, we would not be able to do these sorts of studies if they weren't made accessible to scientists and stored in perpetuity. Through my own fieldwork as an Arctic botanist in Canada, my colleagues and I have made over 8,000 new collections of plants on about 10 expeditions, most in Canadian Arctic areas that have not been explored at all for plant diversity. Every trip confirms that our current knowledge of plant biodiversity is incomplete. We routinely make collections that extend the known range of species by hundreds of kilometers, and we often find species that we did not expect in Arctic environments, like this small grove of stunted balsam poplar, a tree species, that we found well above the tree line on mainland Northwest Territories in 2010. We found many rare plant species on Victoria Island, on southern Baffin Island, that were not previously known from any of the Canadian Arctic islands. And the same pattern holds for all other Arctic groups, and like marine invertebrates living on the seafloor, for which there are huge gaps in baseline biodiversity information. Looking back in time, the fossil record teaches us about the planet's deep past and shows that throughout the Earth's history, there has always been change in the Arctic. About 375 million years ago, today's Arctic islands were part of a tropical supercontinent that spanned the equator. By 50 million years ago, the Canadian Arctic islands had mostly attained their current high-latitude distributions. The climate then was warm, it was ice-free, home to lush forests that we now know from the fossil forests on Axel Heiberg Island, and there were swamps inhabited by alligators, giant tortoises, and large hippo-like mammals, all known from the fossil record. In the Pliocene, about 3.5 million years ago, the Arctic was about 7 degrees warmer on average than today in the summer, and full of life. A few years back, one of the scientists here at the museum discovered on Ellesmere Island several fragments, they weren't lined up quite like this, from the leg bone of a very large mammal. That's all they found on the left. Using some cutting-edge science, she demonstrated these bones belonged to a giant, ancient camel. The first record of a camel ever living in the high Arctic of Canada. Biodiversity in the Arctic today colonized the land and oceans following the retreat of the glaciers that covered most of Canada about 10,000 years ago. Natural history specimens collected over the last 200 years document the current distributions of Arctic biota in time and space. The Arctic environment is now changing faster than it's ever changed before. August and July 2016 are tied for the hottest months ever on planet Earth. The global Arctic is warming twice as fast as the rest of the planet. Arctic ecosystems and biodiversity are changing very rapidly. There's been a documented greening trend across the Arctic over the last 30 years, recorded by satellites, as this image shows, representing an increase in photosynthesis or primary productivity by plants that live there. The darker the shade of green on this illustration, the greater the increase in productivity over the last 3 decades. Boreal fish species are moving northwards, pushing Arctic species even further north. Invasive alien species are expected to increase. Summer ice is disappearing, and orcas and giant cruise ships are moving into Canadian Arctic waters. According to some climate models, the current tree line, shown here on the left in green, may migrate northwards to the Arctic coast, as shown on the right, by the end of the century under a rapidly warming climate. This could result in massive and catastrophic range shifts of boreal and Arctic species. We now are in a race against time to accurately document and track changes to Arctic biodiversity. Natural history specimens are central to this understanding, as they're the best source of proof for the identity and existence of an organism in time and space. But the density of collecting across the Arctic has been much poorer than most of the rest of the planet, as shown on this map of the locations and intensity of biological collecting around the world, based on data based in natural history collections in the world's museum. So in many cases, the necessary baseline information about Arctic species is currently lacking. Continued boots-on-the-ground exploration is needed throughout the Arctic to ensure we have a collection that is representative of Arctic biodiversity through time and space. We must accelerate the collection of natural history specimens today so that we have the solid baseline of information that we can be used to answer the questions of tomorrow. One by one, every collection contributes to knowledge, and every collection has a story. Not all stories have happy endings. These 2 extinct bird species once bred in the low Arctic. Today they're known only from specimens, 55 and 78, that are known in museums around the world. Other Arctic species might have similar fates if they're not able to adapt to climate change. Natural history specimens represent the past, but they inform the future. Arctic biodiversity in the future will look very different than it does today. Continued collection and study of Arctic biodiversity in the past and present will help us understand these changes, one collection at a time. Thank you.